science team member from the University of California in Davis. Andy Mishkin, Integrated Planning and Execution Team Chief from JPL. And Doug Ellison, Visualization Producer at JPL. And we'll begin with Michael Watkins.
Okay, good morning. We had another really fantastic day on Mars. Curiosity, I think, continues to behave basically flawlessly, and executed all the planned activities successfully and nominally yesterday. And it's a good time for me to point out that the team operating Curiosity also is performing basically flawlessly and completing all planned activities as well. It's really just a great day all around. So the Sol 3 activities consist of a couple of things. We're about to do we're about to upgrade our software on the rover. Just like we upgrade our operating system on your home computer and your laptop or something, we're going to do the same thing. We need a new flight software load that is optimized for surface. So we landed on one that was optimized for landing, but landing doesn't have to drive the rover and operate the arm and all that. And by the same token, the surface doesn't have to land the vehicle. So we want to switch to this new flight software that's really optimized for surface operations. And we're going to do that starting tomorrow. Actually, day after tomorrow, sorry. Sol 5 is when we're going to start that activity. So we had to do a little prep work for that activity. We want to check out our backup flight computer and make sure that was healthy and it looks fine. We also sent up some files to get ready for the flight software transition. Now, the other things we did was check out some more of our instruments, do some more health checks on the remaining instruments. And so we checked out the SAM instrument, Chemin, APXS, and DAN, and they all passed those checks successfully. They're all in great shape as far as we know, through the tests that we've done, and that's a great sign. And no anomaly showed up at all in any of those tests. We also took a whole lot of imagery around us. So we took a 360-degree panorama of using the nav cams of the terrain around the rover, and also looked back at ourselves and took a close-up of the deck. We also took the first 360-degree panorama in color that Mike Malin will talk about a little bit, and started to get the first bits of that down. So let me start by showing some of those images.
You can watch it up there, I think.
Just make sure it turns. Okay, so this is our deck pan, and now we're kind of zooming in here. And you can see here that that's actually the RAD instrument, and you can see a few of these kind of large for us pebbles on the surface, and those apparently were kicked up by the landing event. Apparently, our Mars lander engines actually pushed up some of these this gravel kind of stuff, maybe up to about 1 centimeter in size, on top of the rover, and they pose no problem for operations. We do move the black thing there, the differential pivot around, but can easily go over these or crush these, or not even hit them at all, go on top of them. So we don't see any operational constraint by this stuff being there, but it's a little unexpected that it is there. The EDL team, when they analyzed the landing before landing, I think they didn't think they would kick up stuff this large. And so I think they're off looking at that. Maybe these are lighter material than they expected or something like that. But the EDL guys, they have nothing to do now, so they need a problem to go start working on, right? So this is something for them to do. But as I mentioned, we don't see any impact of this. The RAD instrument and our other instruments don't seem to be, they're not covered by any. It's not affecting the science observations. So we think that all that's in pretty good shape. Let's go to the next slide. Okay, so this is just kind of a context shot here. Here we are. You can see the high gain antenna there to that's the hexagonal thing pointed off to the side there, and then behind it, the little thing sticking up is the low gain antenna. Then you can see the rim of the crater off in the distance there, and we also acquired some color pans of this area, and Mike Malin will talk about those.
Thank you, Mike. Here I am again. Only I'm wearing another different hat this time. I'm the principal investigator of the MastCamera. And before, you've seen me here as Marty, the descent imaging, and we got a 360-degree panorama into the sequence from yesterday, and we got our thumbnails back. And I need to tell you that the full frames are now stored inside the camera, and we do have to get those images out of the camera and stored into the rover's memory in order to bring them back home. But today, the SAW we're planning now for is the last SAW we have until after the software activity goes through to get them queued up. So we're going to queue up a few of the full resolution images. Again, what I'm showing you are thumbnails. You should remember back a couple of SAWs ago when I showed you the thumbnail of the heat shield, and then I faded that into the full resolution. That's the kind of difference you should expect to see between what I'm going to show you now and what I'll show you when we get some of the full resolution frames back. So if I can have the animation, please, or video. This is the full 360 panorama. It's the color as it was transmitted, except brightened up. It was pretty dark to begin with. You see there in that area going off to the right now the impact, or the plume impact site of the rocket plumes. We're now panning across the base of Mount Sharp. We see the shadow of some of the hardware on the rover itself. We zoom in because there's a big gap of places we didn't take pictures, so this gives you a better view of the tier of images that we did get. You'll pick up the rim up at the very top and the haze. Haze shows up pretty well in the color. You can see it's slightly different color. You can see it's a low light layer there, as was seen in the NavCam. And then we're going to zoom in here again to look at this is the area that's been discussed. It was shown last time I was here. Grotzinger talked about bedrock and digging up material by the rocket plumes. So if we can keep going now, I think we're going to back out from this and just show you the full mosaic again and zoom in back to the other plumes. And then we're going to zoom back into the plumes. So you can see the plumes are light toned. That could be a contaminant. We don't know. We probably won't know unless we go over and observe these things. Other than that, this is a very low resolution image. The images are only 144 by 144 pixels. There are 130 of them in here. It took us about an hour and 6 minutes to take the mosaic. And with that, I'll hand it off to someone who's going to interpret some of this stuff.
Yeah, so we have these beautiful images, and Mike did a nice job describing some of the interesting features we can see in the early part. We're really looking forward to the full resolution images. We can also see the main reason we chose Gale as a landing site. So if I could have the first slide. So this is the NavCam mosaic, and in the upper right, you can actually see the main target area of where we want to go and why it was chosen. So in the hills at the background at about between 190 and 200 at the degrees at the top, you see these beautiful knolls and of layered rocks, and that is those layers are what's recording the history in Gale Crater, and they are one of the reasons we chose Gale Crater. The main reason is to study those rocks, so we can see those in the distance from where we are, and it's very exciting to think about getting there, but it is quite a ways away. And we also want to be able to take the science that we can do where we landed and integrate that into the mission as well. So next slide. I've been coordinating with some others a mapping effort, and so you can see in this image, you can see the landing ellipse outlined in red, and we've divided the area up into about 1 mile by 1 mile quads or squares, and we had volunteers from the science team map each quad. And what mapping means is looking at the different textures that you can see in the images and mapping the boundaries between those textures. So if we do that for geology on Earth to mark where different types of rocks are outlined. And Curiosity landed in Quad 51, which happens to be one of the ones I mapped. So I'm sure that was intentional by the navigation team. And so what the science team is now doing is we have these individual maps, and we've started integrating them to get the broader picture. and also investigating the rocks and and craters and patterns around where Curiosity is now. And we'll use this map to find a path from where we landed to the main target at the base of Mount Sharp, which is south of where we landed. And so we'll drive on the northwest side of the dunes and go through a break in the dune field. But on the way, we're going to have a lot of interesting geology to look at. And so the team will be balancing observations and scientific investigations on our drive, but also still get to the base of Mount Sharp.